Okay, so let's run a second example of these piecewise functions. Everybody's favorite other letter for a function, probably g. So let's do this one as g of x. And I'm going to get a little more fancy. Let's do this one as 3 different formulas. We'll keep the formulas relatively simple still. We're not trying to do anything super wild. Let's do x cubed minus 4. Let's do a middle one that's just 2x. And let's do a constant function on the bottom that's just 16. So this is 3 different formulas. Let's divvy up the x's. Last time we kind of went bigger x's to smaller x's. That's kind of intuitive to me. I honestly don't know what is standard operating procedure or if there is one. So I'll start with big x's. Let's do a split at x is strictly greater than 4 for the middle one. Let's attach it, right? So let's do x values. What do we want? We want them to be between, let's say, 4 and negative 2. So let's do, right, 4 is strictly, right, greater than, equal to. So we'll include the 4 down here, and let's do strictly greater than negative 2. And then for the last one, we'll do x values that are, right, less than or equal to negative 2. So we have x values, right, that are sort of greater than 4, right? So this is like 4 and above. I'm sorry, it doesn't include the 4. Anything that's bigger than 4. So anything that's bigger than negative 2 up to and including 4. And then anything that's strictly less than negative 2. So starting at negative 2 and then anything that's less than that. So let's just throw a couple random x's in here. Let's do g of negative 3. Let's do g of negative 2. Let's do g of 0. Let's do g of positive 2. Let's do 4. And let's do 6. So we'll just kind of run all these in order. And we'll kind of notate as we go which of these 3 formulas we're doing, right? Sort of top, middle, or bottom. First things first, let's just kind of go from the top to the bottom. So in this case, x is minus 3. Right, this is sort of our smallest number. So this is going to be obviously less than negative 2. So this one's going to go into the bottom. And what that's going to mean for us here, right, you'll notice this bottom function just is a constant function. Right, so this is like g of x just equals 16. That's what we call a constant function. There's no x in this formula, right? So that means no matter what the x value is that I'm trying to sort of use as an input, I'm just going to get 16 as an output, right? There's no place to even sub an x in. So I'm just going to get 16, and that's really all there is to it, right? So without having an actual value x to sub in, we just sort of get what we get, which is 16. At negative 2, that's going to also, right, hit our value here, right, x that's less than or equal to negative 2. So this includes the negative 2 here. So that one's going into the bottom as well, which if this is still a constant function, is still just going to be 16. Right? So our first 2, in this case, are going to the bottom function. We're sort of running these numbers in order, right, from smallest to biggest. So in our formula, we're going to work our way from, right, the bottom here to the middle up to the top. That's what you would expect. X equals 0. X equals 0 is obviously between, right, positive 4 and negative 2. We're definitely in between these 2 values. So that's going to send us into our middle formula. This has an x in it. This is going to be 2 times whatever our x is. So this is 2 times the x value. Although in this case, if our x value is 0, well, 2 times 0 is 0. So that one's pretty easy to calculate. Positive 2, right? Obviously, again, between 4 and negative 2. We don't have to worry about any of these endpoints, strictly greater than or less than. We're just sort of nicely tucked into the middle, so we just crunch it. So this is 2 times our x, which is 2 times the x is also 2. 2 times 2. So the output here, the result is positive 4. Third value, so this is x is positive 4. That's still in our middle function, right? Because if we hit 4 on the nose, we're including that in the middle. The top one doesn't jump up until we cross over 4 and get strictly bigger than it. So this is going to be a third one in the middle. You probably thought that I would balance this to 2 and 2, but I didn't. So let's do 2 times the x. In this case, 2 times 4 is obviously going to send us to 8. You can imagine, right, this section of the graph is going to be this sort of line that's like sloping up, right, sort of between these two coordinates, right? So this is like 2 times x. Our line from the first section, this constant function, right, x is 16, is just going to be sort of a constant value here. Last but not least, so this x cubed minus 4, if we go down to x equals 6. This is strictly bigger than 4, so this is going into the top. We run into the immediate problem that I don't really know what 6 cubed is off the top of my head. Let's sort of crunch this on the spot, I guess. This value cubed minus 4. I guess we'll just sort of crunch this number off to the side, right? So this is x equals 6. I'll just kind of do this over here, 6 cubed, right? That would be 36 times 6, right? Because 36 is 6 squared. 36 times 6. I just like the math so much. I made myself a little extra, right? 6 times 6 is 36. 6 is here, the 3 is here. 6 times 3 is 18, plus the 2 here is going to be 21. So 216 from the 6 cubed minus 4. So what's our result here? 212. You can kind of see in this case, right, this cubing function. We didn't really do a whole lot with cubes yet, but obviously, right, squares get pretty big pretty quick. A cubed function is going to get even bigger, even faster. So even though we're subtracting a little bit off of it, obviously 4 is no match for 216, and we're still up very, very, very high. This is going to have an x cubed typed shape, which is going to be this sort of half of a parabola typed shape. We're not asking you guys to graph any of these at the moment, but in theory you could kind of make a sketch by sort of attaching all these pieces together. We'll maybe save that for a bonus for your imaginations. If you want to see that, you can ask me after class sometime. So there we go. That's the end of 2.2.